Okay, my mic was off. So I'll be attempting the biweekly contest 172 after a while, and I hope it goes well. Let's see what happens. Operations to have distinct elements, given one operation remove first three elements of the array. If there are fewer than three elements remaining, all the elements have to be removed. If operations required. Okay, let's choose Python first. Okay. So, and the length of norms. Set is equal, let's say, was length 10 power 5. Okay. Okay, so f is equal to counter of norms. So for while length of f not equal to the norms, not length of norms, and so if n, so if n lesser than or equal to 3 plus 1. Okay, is equal to 0. Okay, so f of nums of id, okay, for range 3, under the idx is equal to 1 if is equal to list index out of range. Okay, f6. Okay, idx plus equal to 1 and minus equal to 1. Now it should be fine, I think. Okay, so 0 1 0. So the answer is wrong here. Okay, so our result, we should increase it. So 1 1 0 seems right. Let's give it a go. You are given an integer array norms. Your task is to choose exactly 3 integers from norms such that the sum is divisible by 3. Return the maximum possible sum of such a triplet. If no triplet exists, return 0. Okay, 10 power 5. sum is divisible by 3. So we know that if any number, if the number, if any number is divisible by 3, then the sum of the digits should be sum of the digit should be divisible by 3, right? I know what I'm doing. That's not necessary. Okay, so I think it's the remainders we have to take into account. Okay, so what we can do is, okay, so we can have 3 3 3, or we can have 1 2 3. Is that the only thing? The remainder cannot be 3. So, or 0 0 0 0, right? These are the only two possibilities I see. So we can have HM is equal to sort list for norms r is equal to n mod 3 hm dot add uh, hm of r dot add n. So our first condition is temp 1. Okay, so if no triplet exists, we return 0. So return 0 in the end. So if t r1 r2 is equal to 0, turn max of r1 comma r2. So if length of hm of 0 is greater than or equal to 3, then r1 is equal to 0. No, shift n c 2 minus 3 if length of hm of 0 greater than or equal to 1, hm of 1 greater than or equal to 1, length of hm 2 greater than or equal to 1, 2 is equal to you can also have 1 1 1, right? That's also a possibility. 1 1 1. Now if length of hm1 greater than or equal to 3, hm1 r It's a default dictionary word right there. Your first argument must be callable. Soft list. My bad. Okay, so the answers are 9 and 0. 9 and 0 seems valid. Let's check it out. Oh my god, no. Wait, what? Okay, so 8 is to 10, 12. So the remainder is 2, 2, and 1. 2, 2. Wait, no. 2, 2, 2. 2, 2, 2 is also valid. I missed that. Option of 2. Option of 2, 0. Expected 12. Let's see if that works. Why is it so slow? Come on, Leetcode. Oh shit, there's R4. And then, where's my R4? So R4 is equal to that. 4 should be fine. Maximum score after binary swaps. Okay, 9012 seems right. Okay, I think that should be fine. Unless it's time limit. Wrong answer again. What's wrong with my internet? Yeah, it's perfect. So maximum score after binary swaps. You're given an integer array nums of length n and a binary string s of the same length. Okay, so n is equal to length of nums, binary string of the same length. Okay, I think I need a pen and a paper. Initially, your score is 0. Each index I where s of I is equal to 1 contributes the number of I to the score. Okay, so this basically if it's counted or not. You may perform any number of operations including 0. One operation you can choose the index I such that and swap the two characters. Okay, you can swap a 0 and a 1. So one thing I'm going to do is s is equal to list of the string, so that makes everything easier. Does it denoting the maximum score you can achieve? Okay, that's okay. 10 power 5 again. Maximum possible score you can achieve. Isn't that just the number of ones? You may perform any number of operations including 0. Isn't that pretty simple? Wait a second. Nums sort count is equal to s dot count of 1. So for I in range count reverse true in range count, say result is equal to 0 or plus equal to number of I. So power score you can choose. Initial score is 0. So what's the answer? 7 and 0. Wait, that's not the solution. Okay, wait, so we have can't you swap these two and these two? So index I is equal to 0. Wait, given array index, you may choose any index I. Okay, you can only do it with adjacent elements, right? So this seems like a stack solution now. Okay, so let's say we have 2 1 5 2 3 0 1 0 1 0. So every time we get to 1, we need the maximum of the elements up to that point. So let's say it's 0 0 1 1. Okay, number of ones consecutively. Okay, so we can have current is equal to our current is something like a stack. So sorted. Okay, so for nums, if wait, so let's do a while loop. While idx less than n. So if our number is so if s of idx is equal to a 1, then result plus equal to uh sorted list dot pop, right? And then we every time we go to an index, we sorted list dot add, then we add in the current, so nums of idx, so idx plus equal to 1, then we result cannot okay is equal to indented block after. Okay, seems fine. Okay, my bad. Current result. Okay, so result is equal to initially 0. Then seems fine. Required positional argument set. What am I doing? So sloppy today. Okay, 7 0. Is that it? Seems fine. Let's give it a go. Perfect. Okay. So last remaining integer after alternating delete operations. Okay, so what is my rank so far? Okay, you're given an integer n. We write the integers from 0, 1 to n. Okay, what is this? 10 power 15. Okay, given an integer n, we write the integers from 1 to n as sequence from left to right, and alternatively apply the following two operations until Only one integer remains starting from operation. Starting from the left, delete every second number. The right, delete every second number. Point operations until number. Wait, n 578. So 1357. Okay, this is quite interesting. Okay, so we remove one and one, delete every second. So two. Okay, we remove all the. Okay, but how do you? This is quite good. So uh, I'm gonna call it a night. I really wanna have dinner, and yeah, I'm just feeling a little lazy today. But anyway, I think I did pretty well. Solved the first three in like what 20 minutes, but then I got one penalty. So yeah, good night, everyone. Have a nice day.